But what exactly does this mean? Let's dive into this by taking a look at where it started, the data warehouse. The traditional data warehouse has been around since the 1970s and is designed as a structured repository that consolidates data from various sources in a well organized manner for business intelligence and analytical purposes. It aims to provide a single source of truth. Data is cleaned, transformed, and integrated into a structure that is optimized for querying and analysis. But while the traditional data warehouse works well for structured, tabular data, similar to what you'd find in a spreadsheet, it struggles with unstructured and semi structured data, such as images, audio, video, and free-form text files. With the explosion of the internet in the 1990s and early 2000s, the rise of streaming devices, and the rapid pace of data creation and collection, data warehouses fell behind as they could not support this vast influx of unstructured and semi structured data. Additionally, data warehouses are expensive to scale due to vendor costs for compute power and storage capacity. They often use proprietary and closed data formats and are locked on premise with very little flexibility, thus locking a business into a single platform. On the flip side is the data lake, which emerged with the rise of internet and cloud computing in the early 2010s. The data lake was designed to specifically address the limitations of data warehouses and excels at handling the unstructured and semi structured data types. Data lakes made storing large amounts of data convenient and cheap. Raw data could be stored in its original format without any predefined schema, and businesses could consolidate their data into a single centralized location. However, it meant that data in all stages of the refinement process were stored side by side, making it difficult to differentiate between what was original data and what was processed data. Besides this obvious drawback, data lakes were a bit more difficult to set up, as most users were more familiar with the traditional data warehouse. If set up incorrectly and with too lax a design, a data lake could become a data swamp of large amounts of dirty data in unverified and uncontrolled groups, which also raised governance and security issues. So, given these benefits and limitations of both data warehouses and data lakes, many businesses sought to pair them together to try to get the best of both worlds. However, this was easier said than done. As you can imagine, many complications, challenges, and limitations arose with these types of endeavors. Each system had its own set of governance rules and security practices. Data practitioners had to copy data back and forth between the two systems, wasting time, compute power, and storage. And neither platform could support all of the use cases necessary for businesses to scale. Attempting to manage this type of infrastructure was frustrating and complicated, wasting time and adding to the overhead total cost of ownership. So, this is where the data lakehouse comes in. The data lakehouse is the best of both worlds solution. While being built on a data lake where all types and formats of data can be stored side by side, the data lakehouse provides structure and data management features you traditionally find in data warehouses. The data lakehouse unifies the workloads for all data practitioners, simplifies the security and governance structure, and is built on open standards in the cloud to eliminate the vendor lock in that holds back innovation and drives up costs. By merging together data warehouses and data lakes into a single system, teams can move faster as they now have a single unified architecture for all their needs and use cases. Their data is accessible in a single environment without the need to log in or access multiple systems, and they know they'll be getting the most up to date data for their projects. However, with the rise of Gen AI in 2023, additional challenges arose within the modern data ecosystem. The data lakehouse already addressed the proprietary data lock in issue and the siloed security situation, but what about AI and now agent automation? That's when Databricks began the process of integrating AI into the core of the Databricks Lakehouse platform, thereby transforming it from simply a lakehouse architecture into a data intelligence platform. By pulling together the things that were so beneficial about the lakehouse architecture and augmenting it with secure, properly managed AI tuned to a business data, the Databricks Data Intelligence Platform was born to meet the needs of businesses that wanted to get the most from their data to solve their own unique use cases. Data intelligence works by utilizing both generative AI and traditional AI models to develop a comprehensive understanding of your organization's enterprise data and its usage. It learns from signals captured from across your organization's data estate, including its data catalog, SQL queries, BI dashboards, notebooks, data pipelines, and documentation. This approach allows for a nuanced understanding of your business's concepts, semantics, and unique data environment. As a result, the AI can provide significantly more accurate answers compared to the native use of large language models trained solely on public internet data. So, knowing that the Lakehouse architecture addresses the challenges of proprietary data format lock in and disparate data governance and security across multiple platforms used for different use cases, we can now address the situation that has arisen in the last few years around adding Gen AI and AI agents to every platform and software tool a business might use to address their use cases. By pulling these together in a framework that allows you to compose AI agents to suit your unique business needs and use cases, regardless of whether you're doing orchestration, ETL, or data analytics, the platform provides a single location to build out your solution, knowing you are operating in a safe and secure environment with the freshest data available. And as you can see, there are many use cases and more to come that AI agents have been designed to address. By providing a composable agent framework, you get the benefits of this advanced technology without the complication and overhead of having to specifically design the agent yourself. So, with these three solutions in place, the Lakehouse architecture has been transformed into a data intelligence platform. So, how does Databricks deliver on the vision of the data intelligence platform? First, we cover the open formats with Delta Lake and Iceberg for analytics and Postgres for transactional workloads. As a matter of fact, the original founders of both Delta and Iceberg currently work at Databricks. To address unified governance, we have Unity Catalog. This has been a top priority here at Databricks over the last few years because we know your data is valuable and it must be securely managed and properly governed to meet your unique compliance and regulatory requirements. And finally, to address the explosion of Gen AI and AI agent needs, we've developed AgentBricks to provide for all your AI capabilities. This is the foundation for simplifying the architecture of any data ecosystem an enterprise is using. It ensures you are addressing all the needs of a modern data environment to help you scale and accelerate your time to market with your data products. Above this architectural foundation, Databricks provides a suite of products and services to meet the needs of all your data and AI teams, as well as your non-technical business users. Your business may have other products you prefer for these workloads, and that's fine. Everything currently existing in your environment is able to operate in conjunction with Databricks on the common foundation that you see here. However, Databricks does offer a unified approach to solving all your data and AI workloads on a single platform to simplify your data ecosystem architecture. For ingestion, ETL, and streaming, Databricks offers Lakeflow. It includes all the tools and capabilities necessary for data engineering endeavors with Lakeflow Connect, Lakeflow Spark Declarative Pipelines, and Lakeflow Jobs. For data warehousing endeavors, we offer DB-SQL, which is specifically optimized for query execution. For the transactional database side of analytics, we provide Lakebase, which is a transactional database engine where the data is stored in low-cost data lake storage. Databricks Apps is a feature within the platform where you can create custom apps based on your data and deploy them in a secure and consistent manner. And lastly, we have AI BI, which is our tool for agentic business intelligence. The tools available at AI BI help you understand and explore your business with natural language and make data accessible to non-technical business users. So taken all together, the combination of data and AI delivers on the vision of data intelligence. Data democratized through AI, and AI democratized through your data. Here at Databricks, we offer the first data intelligence platform, founded in open source technology with a unified governance framework designed for your entire data workflow. It takes the Lakehouse and makes it a fully data intelligent platform for your data and AI needs. Data lakehouses and data intelligence.